Hello students, we are going to solve extra sums of exercise 1.1. We are already familiar with HCF and we have also proved using this Euclid's division lemma that square of any positive integer in the form of 3m or 3m plus 1, cube of any integer is in the form of 9m plus 1. In that case we have taken b value, the divisor as 3, the multiple of 9, and we proved it very easily, correct? On the same lines, we will prove some more extra sums. Let's go to the first extra sum. Find the largest number that divides 2053 and 967 and leaves a remainder of 5 and 7 respectively. So, find the largest number. So, you have to find the largest number that will divide both this number. So, these are the dividends, and this number, this largest number is the same for both, right? Find the largest number that divides 2053 also and 967. So the divisor, that is b, is same in both the cases and leaves a remainder of 5 and 7. So if I write in the form of Euclid's division lemma, I get this is b into, let's take as quotient as q, and we get this 5. And if I take 967, I take the same divisor b and let the quotient be q1 and the remainder is 7. Correct? If I take this 5 this side, what do I get? 2053 minus 5. That is equal to b into q. So 13 minus 5 will give you 8, 4, 2048 b into q. So what do you understand from this? That now after I have shifted this plus 5 here, so I get 2048 equal to b into q. This means b is a factor of 2048, correct? And if similarly, if I take 7 this side, I get 967 minus 7. So it becomes 960 equal to b into q1, where b is common. And b is the largest number that is going to divide. B is the highest common factor. So now if I write, suppose if I write 2 into 3 equal to 6. That means 2 is a factor of 6, 3 is a factor. So here b is a factor and b is also the factor. And what kind of factor? It is the highest common. That is the highest common factor. So we have to find out the HCF of 2048 and 960 and get the largest number. So to write the step, we just have to write the required number is the HCF of, and we write 2053 minus 5, that is equal to 2048, and 967 minus 7, that is 960. So if you find out the HCF of 2048 and 960, that is your answer. Correct? I hope you have understood this sum. Let's move to the next sum. Show that p square will leave a remainder 1 when divided by 8 if p is an odd integer. So p square means square of any integer. But what kind of integer it is? Odd integer. P square. So square of any odd integer when divided by 8, it will leave a remainder 1. It will leave a remainder 1. So the same question can be framed at, show that square of any odd integer when divided by 8 will be of the form 8m plus 1. Okay. So if this kind of sum is given, now b is 8, we have understood that b is 8. So there are 8 possible values. In that 8 possible values, 4 are even and 4 are odd. Because we have to only stick to p's odd integer. So odd integer means 8q plus 1, 8q plus 3, 8q plus 5, 8q plus 7. So we only have to check for that 4 cases, and we prove that square if you take, you have to find whether it leaves a remainder 1 or it is in the form of 8m plus 1. I think the same type of extra sums I have already given. I have just changed the format of the question. So both are same. So in this case, we should, instead of taking 4 cases, so if I say that b is 8, 4 even and 4 odd, so 8q plus, if you take the square, you can do that way. If you take the multiple of 8, if I take b as 4, then we have already proved that, show that, we have a textual question. What does it say? That show that any positive integer is in the form of 4q, 4q plus 1, 4q plus 2, 4q plus 3. And odd integer will be in the form of 4q plus 1 or 4q plus 3. So if b is 4, if I take odd integer, there are only 2 cases, 4q plus 1 and 4q plus 3. And if I take the square of this, what do I get? I get 16q square plus 8q plus 1. And this can be written as 8 into 2q square plus q plus 1. So this is in the form of 8 into something plus 1. So it leaves a remainder 1. Similarly, if I take the square of this, you will also get in the format 8 into something plus 1. Right? I hope this is understood. Why I am stressing on this? That when I take B as 8, we will get 4 cases of odd. So 4 cases means it is little time consuming. So instead of B equal to 8, you can take also B equal to 4, provided what they have asked, that condition is fulfilled. Correct? I hope you have understood. Like I am just trying to correlate the textual question and the extra question. So the hint, if it is given, then it will be easy for you. See, the content, the length of the question answer doesn't matter in both. It is the content. Have you fulfilled what they have asked? That's it. Correct? Moving to the next sum. Please read the sum. Prove that n cube minus n is divisible by 6 for any positive integer n. N cube minus n is divisible by 6. So from the first line we understood there's something b as 6, correct? And here we also have n cube minus n. So that looks like, what is n cube minus n? We have not done this kind of sum. So when I try to simplify this n cube minus n, let's take n common, correct? Let's factorize it, simplify it. So we get in this format. Can I simplify further? This is in the form of identity a square minus b square. So we'll get n minus 1, n plus 1. Can I write in the ascending order? So this becomes n minus 1, n and n plus 1. Correct? So this is like, here you can find out this is nothing but it's the product of 3 consecutive integer. Product of 3 consecutive integer. So if this question can be asked, this question can also be asked in the form of prove that product of 3 consecutive integer is divisible by 6. Same answer. You can also take n plus 1, n plus 2. But this way also we can take. So the question is the same, but it is asked in a different way. So prove that product of 3 consecutive integer is divisible by 6. Let's understand with the practical example and then so on. Product of 3 consecutive integer if I take, let's understand 1, 2, 3. If I take the product of this, is it divisible by 6? Yes. If I take 4, 5, 6, or if I take this 3, 4, 5, 3 4s are 12, it's divisible by 6. 4, 5, 6, 6 4s are 24, divisible by 6. So this is there practically, but we have to prove using Euclid's division lemma. Now there are 2 ways of proving this. Now since the B is 6, you can use a test of divisibility for a 6. If a number is divisible by 2 and 3, then we say the number is divisible by 6 also. So in that case, you can take B as 2, prove 2 cases. You can take B as 3, and we'll have 3 cases when R is 0, 1, 2, right? And then we can say therefore if the number is divisible by 2 also and 3 also, then the number is divisible by 6 also, correct? That is one way. Now today I am going to solve by taking B equal to 6 because only one more additional case. And this is a 4 marker sum. So when B is 6, so only one additional step, that is why I am taking and solving this. So one more additional case, right? So here I am solving the second method by keeping B as 6 only. So let's start the proof. So here we have n cube minus n, we have simplified. You can do by that method also, it is one and the same. When you understand this how to solve, then automatically you understand for 2 and 3 also you have to solve by same way. The other way what I am talking about. Let n be any positive integer, okay, any positive integer, and here in this case I am taking B as 6, okay. Now if I take, therefore by Euclid's division lemma, n will be equal to 6q plus r, 0 less than equal to r less than 6. Now here I am drawing the line so that there are many cases, right? So we can solve. So here, what are the possible values of r? R will be 0, 1, 2, 3, 4, 5, correct? So what are the possible values of n? N will be equal to 6q plus 0 Then when r is 1, then n will be equal to 6 cube plus 1, or n will be equal to 6 cube plus 2, or n equal to 6 cube plus 3, or n equal to 6 cube plus 4, or n equal to 6 cube plus 5, right? So we have total 6 cases. Now we have to prove that divisible by 6. So what should be our aim? We have to bring in the format of 6 into. If I brought 6 into something, that means it is divisible by 6, correct? So let's go. So there are total 6 cases, students. So I will be doing only the first 3 cases. Remaining 3 will be for you. I think when the concept is understood, then I hope you will be doing it very easily, right? Let's do the first. Case 1. Case 1, I am taking n equal to 6 cube. If n is 6 cube, then we will do then n into n minus 1 into n plus 1. What will you get? So instead of n, you will substitute this value. So instead of n, you will put 6 cube minus 1 into 6 cube into 6 cube plus 1. Correct? Now see, just here students, here already 6 is there. You don't have to do anything. Just take 6 common and you can write 6 cube minus 1 inside. Here cube will remain because I have taken 6 outside, and you just write 6 cube plus 1. So what do you understand? Close the bracket. Is divisible by 6. Is it simple? Yes, we have proved 6 into something, therefore divisible by 6. Let's take case 2. Case 2, if n equal to, let's take second case, 6 cube plus 1. So if I take 6 cube plus 1, again we will do the same thing. We will find n minus 1 into n plus 1. What will you get? We will get, this is equals to, I'll just do here. So n is in my case 6 cube plus 1. So here I get 6 cube plus 1 minus 1, because n, this is my n, minus 1 into n. So 6 cube plus 1, correct? And here we have 6 cube plus 1 plus 1. Again I explain, this is in the form of n minus 1. This is n and this is n plus 1. So I have taken here my n is 6 cube plus 1. So if I simplify this, I'll get this plus 1 minus 1 will cancel. So I'm left with 6 here, 6 cube, and here I'll get the bracket 6 cube plus 1, and here I'm having 6 cube plus 2. So can I write this in the form of 6 into 6 cube plus 1, 6 cube plus 2. So here I can say is divisible by 6. Second case is proved. Case 3. Let me take the case 3 when n equals to 6 cube plus 2. Therefore, n minus 1 into n plus 1. Sorry, n plus 1. So in this case, now n you will take as 6 cube plus 2. So wherever n, you will put 6 cube plus 2. 6 cube plus 2 minus 1 into 6 cube plus 2 into 6 cube plus 2 plus 1. Correct? So here 2 minus 1 will give you plus 1. And here, can I take 2 common here? Yes. So 2 if I take common, what will I get? 3 cube plus 1. And here can you see 6 cube plus 3. So 6 cube plus 3, if I write 6 cube plus 3, can I take 3 common here? So what will I get? 3 2s are 6, 3 1s are 3. So now can you find that 2 and 3 is there? 2 3s are 6. So again I can write common 6 cube plus 1, 3 cube plus 1 and 2 cube plus 1. So again you have brought in the format 6 into something, right? So starting 3 cases I have done for you. So remaining case also you have to just see that can I take common and bring 2 and 3 out, so that I make a combination of 6 into something and prove that it is divisible by 6. Okay, so remaining 3 cases will be done by you similarly, and then at the last you write therefore n cube minus n is divisible by 6 for any positive integer, or product of 3 consecutive integers is divisible by 6. I hope this question is understood. It's very clear. It's really very simple provided you follow just the steps. Moving to the next sum. Here, this is also very important. Show that one and only one 1 and only 1 out of n plus 2, n plus 4 is divisible by 3, where n is any positive integer. So here b value is 3. We understood that divisible by 3. So b is 3. So there are 3 possible cases. n plus 2, n plus 4. So before we solve this sum, let's understand the practical example. Suppose here they have given n plus 2, n plus 4. Let's take n value as 1. So here if I take n as 1, what will I get? 1 plus 2, 3. 1 plus 4 will be 5. So here we can see it is a pattern of odd integer. If I put n equal to 2, what will I get? 2. 2 plus 2, 4. And 2 plus 4, 6. So here n plus 2, we all know that even set of integer or an odd integer, the difference is always 2. So here they are trying to say either even set of integer or an odd set of integer, when you take a 3 set, that is 3 consecutive set, n plus 2, n plus 4, only one number will be divisible by 3. That is what the question says. So that one and only one out of n plus 2, n plus 4 is divisible by 3. So let's take an example. See, 1, 3, 5 I have taken. 3 is divisible by 3. Right? Now in the next set of integer, if I take odd integer 7, 9, 11. 9 is divisible by 3. So only one number is divisible by 3. Similarly, when I take even 2, 4, 6, the next set 8, 10, 12. So 12 is divisible by 3. Right? So when I take each set out of 3, so they differ by 2, 2, 2, n plus 2, n plus 4. So each set, only one number will be divisible by 3. That is what it said. So if I take 6, 8, 10, 6, 8, 10. So 6 is divisible by 3. Correct? That we have to prove using Euclid's division lemma. So here, let's see how we are going to prove it. So here again, let n be any positive integer. So it's a blah blah I'm not going to write. You have to understand. Let n be any positive integer and b equal to 3. I think this is clear. And when b is 3, how many possible cases we have? 3 cases. So therefore by Euclid's division lemma, we have n equal to 3q plus r, 0 less than equal to r less than 3. So what are the possible values of r? R is 0, 1, 2, 0, 1, 2. Correct? Therefore, you have as 0, if r possible values is 0, 1, 2. Therefore, what are the possible values of n? N will be 3q, n will be equal to 3q plus 1 and n will be equal to 3q plus 2. Right? Now, what are we going to prove? That there are 3 possible cases. Now, in these 3 possible cases, if I take any case 1, if I take for case 1, only in one set you will find that it is divisible by 3. One set of number. In that 3, that means in 3 cases, one and only one case you will find that the number is divisible by 3. Let's take case 1. Case 1, n equal to 3q. Now, when I take n equal to 3q, now in this format, if n is 3q, let's take first n as 3q. So, n plus 2, n plus 4. What will be the next the consecutive numbers if n is 3q? Then you can find 3 into something. That means it is divisible by 3. By default, it is 3 into something. It is n plus 2. For the same case, if I take n plus 2, what is the next consecutive integer? 3q plus 2. Instead of n, I put 3q. Is it divisible? Can I take 3 common? No. So, it's not divisible by 3. For the same n, if I take the next n plus 4, 3q plus 4, then you find that it is not divisible by 3. Correct? Let's take case 2. So from case 1, you must have understood that there are 3 possible n plus 2, n plus 4. Only one set, that is only one number is divisible by 3. Case 2, when n equal to 3q plus 1. Is it divisible? So if n is 3q, again I write. So if n is 3q plus 1, is it divisible? Not divisible. I cannot write in the form of 3 into something. Not divisible by 3. If n equal to second case n plus 2, if I take. So n, instead of n, you are going to write 3q plus 1. So 3q plus 1 plus 2, which is nothing but 3q plus 3. So can I take 3 common, students? Yes. So 3 into something. So is it divisible? Yes. N plus 2 is divisible. Now if I take n plus 4. Now my n value is 3q plus 1. So 3q plus 1 plus 4, that will give you 3q plus 5, which cannot be taken common 3 into. So it is not divisible. I hope now you must have understood. So case 3, if I take n equal to 3q plus 2. So if n is 3q plus 2, then you have first case n equal to 3q plus 2. Is it divisible? No, I cannot write in the form of 3 into something. Second case n plus 2. If I take, so n is 3q plus 2. So 3q plus 2 plus 2. So 3q plus 4. Is it divisible? Not divisible. Second n plus 4. If I take 3q plus 2 plus 4. So here we have 3q plus 6. And now it is divisible because you can write 3 into 2 is divisible. So in each case, only one number is divisible by 3. Correct? I hope you have understood this extra question very nicely. Do practice it by numbers, first by understanding by practicality. Once you understand, then just you have to put in words. Same words are repeated. We are writing what is A, what is N, and then by Euclid's division algorithm, when you practice it, then you can be very perfect. Okay, bye, thank you.